All right, guys, welcome to these set of notes. I'm going to get straight into it. Today is a second day of arithmetic sequences and writing more sequences, but we're going to talk about a new formula called the explicit formula. What I have at the top of your notes are some definitions. We're going to do a quick recap. So just real quick, general definition of a sequence. It's a function whose set of inputs, the domain, is a subset of the natural numbers 1, 2, 3, 4. So what they're talking about is like the first term, second term, third term, fourth term, etc. A sequence is often showed as an ordered list of numbers. Okay? Ordered list of numbers called the terms or elements of the sequence. Sequence function notation can be tricky. And so you'll see that today. We're going to be learning 2 formulas, and then later this school year you'll be learning more formulas with geometric sequences. So note cards to kind of help keep that separated and memorized. But coming back real quick, this ordered list of numbers, this is, how we had those sets of numbers that we worked with at the beginning of our functions unit. Okay, that's how these can be written. Now, an arithmetic sequence, it's related to linear functions. In fact, is a type of linear function. It's a discrete linear function. So remember the difference between discrete and continuous. Discrete are individual points. They will not be connected points for a continuous line. Okay, so when we graph them, we got to make sure that we don't connect the dots. Common difference, nothing new here. Just remember it's the difference between 2 consecutive terms. I have recursive formula on here again for you as a reminder when we are working with it on these notes. This new formula, explicit formula, what's nice with that one, it's used to find a specific term. So to find a specific term in the sequence. So remember with recursive, the way that we work those out, it was you're finding the first few terms and but it would be a pain in the butt to maybe find like the 51st term because you would have to find out all the previous terms all the way up to 50 to find the 51st. Now this one you can use a specific one, a specific term, it would go into our formula. So real quick, the first term or sequence is right here. Then a specific term that you're looking for goes right there, and then we have the common difference. So I know it didn't show very well on the notes, so just kind of draw those arrows to help you out. Now the other thing that I'm going to write is other ways to rewrite this formula. So a sub n is equal to, if you wanted to make it look like more like a linear function, we could write common difference first, then n minus 1, and then that first term last. And that would be, so your d is similar to slope, and your a sub 1 is similar to that starting point. Okay? Let's go ahead and get started here. We're going to write an explicit formula for each recursive. So notice recursive's given to us, and we're going to put it into explicit. Okay, so just moving this up for you. The first thing I'm going to do is I'm going to identify my common difference. So my common difference is 4. Okay, and then from here, let's go ahead and make our substitutions into this or this. So a sub n is equal to, we're going to start with our first term. The first term is 7. Okay, and then from here, we are going to add on n minus 1 times our common difference, and in this case, it's 4. And then what we're going to do from here is we're going to simplify. So 7, and then we have to distribute. So it's going to be plus 4n minus 4. We keep simplifying, and I'm going to write it so now it looks like slope-intercept form. So I have my common difference, or 4n plus 3. Okay. Now for problem number 2, same thing. We're going to go ahead and start by labeling our common difference, which is negative 3. And then from here, we're going to go ahead and make our substitutions from the information given to us into explicit formula. So a sub n. Now this time I'm actually going to use this other equation where it was just rearranged slightly. So I'm going to write my common difference first. So negative 3 times n minus 1, and then my first term is 10, so plus 10. A sub n is equal to negative 3n plus 3 plus 10. A sub n is equal to negative 3n plus 13. Now the reason I liked it in this form, rewriting it, is notice that you're going to be combining like terms and the terms are right next to each other. And then I don't have to distribute backwards, I can just distribute forwards. Okay, we'll do 3 next time I see you in class. So let's go ahead and move on to number 4. So for number 4, what we're going to do is now we're going from explicit to recursive. So write a recursive formula for each explicit and find the first term of the sequence. So I'm going to write it here at the end because you can't see it because I pushed the notes up. Recursive formula is a sub n is equal to a and then sub n minus 1 plus d. Okay? So let's go ahead and get started using this information and connecting to what we just created or here at the top. I'm going to write down the common difference. The common difference is kind of like your slope. It's right next to that variable, so it is 1/2. And we have to start by finding that first term. So to find that first term, it's going to be 1 plus 1/2. And so since we're trying to find that first term, I'm going to put 1 in for n. Okay? And then I just simplify. And 1/2 times 1 is 1/2. 1 plus 1/2 is 3/2. Okay? And so we have our first term. Now let's go ahead and go into recursive. Okay, so that's always there with recursive formula. Then your common difference was that 1/2 that we wrote down. So we found our recursive formula and we found our first term. Okay? So let's go ahead and try number 5. So for number 5, same thing. Let's figure out our common difference. Our common difference here is 3. And then let's go ahead and find that first term. So since we're finding that first term, we're writing a sub 1 plus 3. Instead of writing n, we're writing 1 since we're finding that first term. A sub 1 is equal to, well, 8 plus 3 is 11. So this is my first term. Next, recursive formula, a sub n is equal to, and again, I'm just using the formula I wrote down, a sub n minus 1, and then plus your common difference, which was 3. Okay, and that's it. All right, we'll do 6 next time I see you in class. So let's go ahead and flip the page. So what we're going to do is we are going to go ahead and get started with using more of this explicit formula to find specific terms, okay? So what I'm going to do at the top is just recopy that formula so we have access to it so I don't have to keep flipping back and forth. So a sub n is equal to, and then I'm going to write that common difference first, n minus 1, and then plus a sub 1, that first term right there at the end. Okay, so I'm going to go just identify a few key information from problem number 7. So problem number 7, the common difference, so from 7 to 13, I add 6, 13 to 19, I keep adding 6, and then just checking my common difference is 6. And then my first term is 7. Okay, so a sub set n, I want this information written down. So we have that for when we plug everything into our formula. So we're going to start by writing our common difference, n minus 1, okay, and then plus your first term. And then from here we're going to simplify. We get 6n minus 6 plus 7, and then a sub n is equal to 6n plus 1. This right here is my rule. Okay, so this is a rule where I can find for any term that I want. So we're trying to find the 19th term, right? So I'm going to go ahead and write a sub 19 is equal to 6 times 19 plus 1. So I just put 19 in for n. So you see the substitutions for n are now 19. 6 times 19 is 114 plus 1 is 115. Okay, that's what we're doing here. Okay, so let's go ahead and try the same thing for number 8. So for number 8, figure out your common difference. Each time we add 6, so my common difference is 6 again. My first term, a sub 1, is 30. Now let's substitute this information into the formula. So a sub n is equal to 6 for my common difference, n minus 1 is part of the formula, then my first term, which is 30. Then I simplify. A sub n is equal to 6n minus 6 plus 30. A sub n is equal to 6n, you're going to kill me because I see my typo. I'm looking at the wrong problem and I'm just rushing through. So my common difference is negative 4. Sorry guys, I know I shouldn't rush, but I just glanced at my phone and I got a phone call from my kids' school, so I got to do that here quickly. So anyway, we have plus 34. When we simplify, this is my rule. Then we have to find the 19th term. So it's going to be a sub 19 is equal to negative 4. We're looking for the 19th term. Add on that 34. I just put this all into the calculator and I get negative 42. All right. So we're going to go ahead and do the next two the next time I see you in class. And so hopefully with any confusions I might have made with problem number 8, I'll clarify that next time I see you. Let's go ahead and do number 11. So number 11 we'll do together right now, and then 12 we'll save that for class. So we're going to focus on number 11. Number 11 is our first story problem. You visit the Grand Canyon and drop a penny off the edge of the cliff. The distance the penny will fall is 16 feet. For the first second, 48 feet, the next second, 80 feet, the third second, and so on. We're going to write a formula to represent this sequence. So we're writing that rule first. Okay, so the first thing I'm going to do is I'm just going to write down my sequence. It went 16, 48, and then 80. That's my sequence, okay? From my sequence, I'm going to figure out my common difference. My common difference for each one of these looks like I increased by 32. A sub 1, my first term is 16. Now, let's substitute this into our formula. So it is a sub n is equal to 32, parentheses n minus 1, plus 16. Okay, so 32 for my common difference, and then my first term. Then we simplify. A sub n is equal to 32n minus 32 plus 16. A sub n is equal to 32n minus 16. So this is my rule for this scenario. Okay. We want to know how far the penny traveled after 6 seconds. So since we're looking for 6, 6 is our sixth term, we're going to substitute 6 in for n. So what that will look like is a sub 6 is equal to 32 times 16. I'm sorry, times 6 minus 16, again, from my rule. And then we just simplify, and we get 176 feet. Okay? All right, I know it's moving along pretty quickly with a lot of time that has passed, but we are going to do one more problem together. So we are going to do 14 right now together. So let's go ahead and consider this sequence defined by the formula a times n is equal to 2n plus 1. Okay, we're going to write out the first 5 elements of this sequence. Your paper should have more space, but looks like maybe not. So I have a1, okay, our first term. A2 will be our second term. A times 3 for our third. I'm going to come over here for our fourth. A times 4 for our fourth, and a times 5. Okay, so we're looking for each of these terms. That's the first 5 elements. Then we're going to go ahead and use this rule. So since I'm looking for the first term, I'm going to put 1 in for n plus 1. And then I simplify. 2 times 1 is 2 plus 1, that's 3. That's my first term. And that's what we're going to keep doing. We're going to substitute 2 in for n. Then I get 4 plus 1, which is 5. Then I put 3 in for n. Okay. And then we will keep going. Put 4 in for n and keep simplifying. 5 in for n, 10 plus 1, we get 11. Okay? Now it says to graph the sequence on the grid shown below. This is our domain. Okay, so remember that is talking about domain. And we'll plot these points. So we'll practice doing that. So for my x-axis, it's going to go 1, 2, 3, 4, 5. Now I could probably go by intervals of 1 for my y-axis. So I'm going to go ahead and write that down. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, and 12. And to find our ordered pairs, so our first term is at 3, so we'll have 1, 3. Okay? Our second term is at 5, so we'll have 2, 5. Third term, the way we can think about this is my input and my output is 7. Or my domain is 4 and my range is 9. My x is 5, my y is 11. So different ways you can think about that to plot your points. Now we are going to remember, I talked about this at the beginning of the notes. This is a sequence. It is going to be a discrete linear function. We are not going to connect the dots to make a straight line. So part C says, why shouldn't we connect the points plotted with a continuous straight line? So again, sequences are only defined for inputs that are positive whole numbers. We can also put in here how it is a discrete linear function. So sequences are a discrete linear function. Okay, and so I think that's good enough. What is the 21st term of the sequence? Show how you arrived at your answer. So now my domain is 21, okay? And we'll go ahead, or my input is 21, and we'll solve for the output. And so we put 21 in for n. 2 times 21 is 42, plus 1, we get 43. And this right here is showing my work and showing how I came up with this. Okay, that's it for these notes. I will see you guys next time in class.